We tried to calculate the area of the logo, and it's built up of three shapes. We have this sector, and then we have this triangle, and this triangle. And when we add together all of those, that's going to give us the total area. So we've got an outline of a plan of how we're going to work this out. Now, the area of a triangle, half base times height, we can't really use here, but we can use the second formula, and that's that half AB sine C, that's equal to the area. Now, we could just show that this is the case. Like if we were to draw a rectangle, clearly that is base times height. Because we had a side of 3 and a side of 2. We got an area of 6. Now, if I did a triangle out of this, I can just divide it into 2. And this is where we get half of the base times the height. It's basically just half of a rectangle. But if we didn't know the height, I can essentially turn this into a right angle triangle and calculate the heights using the values we know. So if I knew 2 of these values, I can do some trigonometry and I can work out the height. So this formula down here is essentially the same as the half base times height, except it's shortened it for calculating the height. You just put the trigonometric function in for you. We could go over that if we wanted to and show that that is true. Or maybe that's something you could do yourself to see that that is the case. So this is our area of one of the triangles, and we have 2 of those. And if we times a half by 2, that just vanishes. We get AB sine C. So that's the area of the triangles. We now need to work out the area of a sector. Now a sector is basically just part of a circle. So let's draw that circle around. Not very well done, but you can see we've got a fraction of that. To work out the fraction we have, in a circle there is 360 degrees in total. And out of those 360, we have 108 of those degrees. The area of a circle, that's pi r squared. So this fraction of the area of the circle, that tells us the sector. So if we add both of these together, we're going to get the area of the logo. We have A. A is equal to 15. B, that's 26. And then sine of the angle in between, that's sine C. And then we're adding 108 over 360 times by pi times radius, which we don't have. That's something we need to calculate here. So let's go up here and see how we can calculate the radius. We don't have any lengths on the sector. We don't have anything other than the angle on the sector, so we can't really work from the sector. We have to work from the triangle. And this radius lies on the triangle. Here we can use the cosine rule because we've got 2 sides and the angle in between them. So that's useful for finding out the other side opposite the angle. The cosine rule is a squared is equal to b squared plus c squared minus 2 lots of b, c, cosine the angle in between, which is cosine a. We're trying to find this side here. So if I just square root all of that, then that's what we need to use here. Now I can just plug in the numbers. So b, let's say that that's 26. C, let's say that that's 15. And then times cosine of the angle, which is cosine 38. And we're doing the square root of all that, which you can put straight into a calculator. And we get 16.9 something. I'm just going to store that as an answer on the calculator and put it straight in here. So when we put all this into a calculator, this time I'm going to use ANS, the answer button, to recall the previous answer. We get some good news, and that's that it's equal to 509.988017. I'm just going to quote it as like that and put ... to signify that it carries on, which is going to be 510 to two significant figures. So just to finish, I'm going to say that that's equal to 510. If you wanted to, you can put 2SF, which stands for significant figures.